It came from a chemical company that was in cahoots with the Nazis and now is part of the GMO big agribusiness industry. Welcome to the True Health Report. I'm Dr. Andy Kaufman, recovering physician, pandemic whistleblower, natural healing pedagogue, and legal code talker. You can call me the Truth Doctor. My mission is to shift your paradigm as we dive into radical forensic dissections, discerning fact from fiction, science from pseudoscience, medicine from poison, law from legal fiction, and individualism from collectivism. This podcast is your channel for unraveling the truth about health and science. Together, we'll challenge the narratives, expose the fallacies, and empower you to become your own health authority. This is the True Health Report, where critical appraisal fuels true freedom. Welcome to the True Health Report. I'm your host, Dr. Andy Kaufman. Today, I'm going to speak about a controversial treatment which is both used in mainstream allopathic medicine and also among some in the alternative circles, and is considered to be a potent remedy. And there are some people who even take this on a daily basis in an ongoing fashion over time. And I am talking about methylene blue. Now, methylene blue was first invented in 1876, and it comes from the chemical dye industry, the same industry that led to the development of antibiotics and other pharmaceuticals. And this occurred because they were developing these dyes for a number of applications, such as textiles, for example, but also they were using these to stain biological specimens to look under the microscope for biological research. And what they noticed is that once the dyes were applied, that the microorganisms were not able to survive, and this led to them being developed as antibiotic agents. So let me bring up my slides, and I'm going to talk a little bit about the origin of methylene blue, where it came from. I'm going to highlight the use cases or what's reported in the medical research literature as possible benefits or standard indications. And then we're going to talk about the risks of taking methylene blue after that, and I'll give a little bit of a synopsis at the end. So Heinrich Caro was the chemist who is credited with first synthesizing or inventing methylene blue, and he used coal tar as a starting material, so not petroleum. But this chemical, methylene blue, is actually known to be the first fully synthetic, quote unquote, medicine or pharmaceutical that ever came into existence. And Heinrich Caro was working at BASF at the time he first synthesized methylene blue. Now, BASF is a very interesting German company because in its history, and this was, of course, after Heinrich Caro's time, it became part of the IG Farben conglomerate, which was involved with the Nazi Party during World War II. And today, BASF or BASF is still in existence. And in fact, they are known as one of the big four agrochemical agribusiness companies. So with Cargill and the others, like making GMO products and chemicals for agriculture primarily, but probably also pharmaceuticals and other things. Now, we have the chemical structure up on the slide here, and there are two forms. And you may see, if you look at the research literature, LMB or leukomethylene blue, which is the reduced form, but methylene blue itself, which is the most common form and the one we're going to talk about today, is in the oxidized form. But with redox chemistry, right, oxidation reduction, and I'm not going to get too technical during this lecture, but these things can convert from one to the other under certain circumstances. And this is actually instrumental to how it's said to be effective in certain conditions, but we'll see, is it actually as effective as claimed? All right, so if I advance to the next slide here we see a commercially available preparation of methylene blue on the left in the injectable vial, and it lists the two indications. Number one is methemoglobinemia, and I'll explain what that is in a moment. And number two is said here to be refractory distributive shock, which essentially means septic shock. So someone has a massive infection in their blood, and as a result, they have lost all their blood pressure. It could also be related to anaphylactic shock, where once again, they would not be able to maintain their blood pressure. And refractory means that the typical things that they do in that situation, which are use a type of drug called vasopressors, like epinephrine actually does serve this purpose, but they would use most likely other drugs like phenylephrine, the same kind of drugs that some are used in the nasal decongestant sprays, actually. So if those fail, then methylene blue. But methemoglobinemia is more of a standard thing that if you go to a hospital with this condition, they will give you methylene blue most likely. So the panel on the right shows methemoglobinemia, and it is basically a condition of poisoning. Some pharmaceuticals can cause it, various types of chemical poisons, and even some types of poison plants, like there's a certain type, I think it's called broad beans, that can cause this. And what happens is that the iron in your hemoglobin goes to a ferric state or a different oxidation state where it cannot bind oxygen. And this, of course, results in cyanosis, which is the bluish color that you could see perhaps around the mouth and lips or in the fingertips in the extremities. And when they give more oxygen, it doesn't help because it's not a problem with low oxygen or oxygen exchange in the lungs. It's a problem with the iron in the wrong oxidation state. So whatever the toxin was that caused this condition, it essentially caused the iron to lose an electron and become reduced and further into a 3+ state, so it can no longer bind the oxygen. So what we need to do is oxidize it back to the reduced state. So let's see how that's said to have done. And let me also say that methemoglobinemia is a pretty rare condition. So this methylene blue at the hospital may sit on the shelf for quite a long time before someone comes in with this condition and they use it. But this is a schematic of two paired chemical reactions that occur with methylene blue that are said to cause the hemoglobin or the methemoglobin to be reduced back to the normal oxidation state. Now, this is very interesting here because it relies on NADPH. So in other words, if you look at the top middle of this slide, methylene blue is added to the equation, and the bottom right is the bad or the methemoglobin. So that's what we want to get rid of. Now you'll see that you can't go to the right down to the right from the methylene blue because the arrow is the wrong way. You have to go down to the left. And you see that methylene blue first has to be reduced to leukomethylene blue, or LMB, by NADPH. And then it can exchange electrons with the methemoglobin and reduce the methemoglobin as it regenerates back to its oxidized form. So in other words, this whole situation is dependent on NADPH. So what would happen if NADPH was not there? or the concentration of methylene blue was so high that it could react directly with the hemoglobin, it would actually oxidize the hemoglobin, causing methemoglobin in either of those situations. And now that we've said that theoretically, we can actually go into the literature. Now, this is from PubChem, and all these dark slides are going to be from PubChem, which is a resource set up by the government in the United States. And I apologize that the text is so small here, but I'm going to read it, and you can certainly look all of this up yourself. But it says here, high IV dosage or high local concentrations of methylene blue may cause formation of methemoglobin and cyanosis, which is a symptom of methemoglobinemia. So we can see here that while methylene blue is said to be the antidote for methemoglobinemia, it also can actually cause methemoglobinemia. So in my opinion, this is not a very good criteria for a life-saving drug. So what else has methylene blue been claimed or tested to help with in a clinical situation? Well, I mentioned on the other slide that it's used in septic shock, right? It said distributive shock there, and one type is septic shock. So here is a paper, and this is written by a pharmacologist, about all of the published studies at the time as of 2010 for methylene blue and septic shock. And I'll read the quote. Observational studies with methylene blue have demonstrated beneficial effects on hemodynamic parameters and oxygen delivery, but use of methylene blue may be limited by adverse pulmonary effects. Methylene blue administration is associated with increases in mean arterial pressure while reducing catecholamine requirements in patients experiencing septic shock. However, its effect on morbidity and mortality remain unknown. So let me translate this into simpler language for those of you not used to reading medical papers. So they don't have proper randomized control studies on this because we're talking about people who are in septic shock. That means that they're probably unconscious, or they may not be thinking clearly, and they're in a life-threatening situation. So it's very difficult to do a trial in that situation and get people's agreement when they would give methylene blue to some people and a placebo to other people. So instead of that, they just give methylene blue to some people and write down what happens. And that's what an observational study. And what they say is beneficial effects on hemodynamic parameters and oxygen delivery means that the blood pressure goes up. And because in shock, the blood pressure is bottoming out. And when there's not enough pressure, the blood can't get around the body to the organs. So if the pressure is increased with drugs, then the blood can get to the organs and deliver the oxygen. So that's what was improved. However, it said it was limited by adverse pulmonary effects, which is lung toxicity. So it's not very good to distribute the blood around when the lungs can't oxygenate the blood, is essentially what they're saying. And then they also kind of reiterated this by specific hemodynamic parameters, and they mentioned mean arterial pressure, which is what I was talking about with increasing the blood pressure and reducing the requirement for other types of drugs that increase the blood pressure, like phenylephrine that I mentioned before. However, the effect on morbidity and mortality remain unknown. In other words, through these observational studies, while they saw it might help increase the blood pressure, they saw that it caused problems with the lungs. They didn't see any improvement in the patient's overall condition, nor did they see any improvement in how long the patient lived. Okay, so in other words, is it a real benefit or is it just a benefit of numbers on a screen? So another area this has been looked at is as an antibiotic. And if you recall earlier when I was talking about how the chemical dye industry transitioned over to antibiotics, this is no exception. So this is a review article of its investigation against different, well, it says it's against methicillin-resistant Staph aureus or MRSA, and that is the so-called one of the superbugs that is present in many hospitals and said to cause a lot of illness. So it says here, many studies have reported that methylene blue on its own or in combination with other compounds has antibacterial activity against E. coli, Pseudomonas, Staphylococcus aureus, Staphylococcus epidermidis, Candida albicans, and Aspergillus niger. Now, several of those are the normal bacteria that live in our body, including E. coli, Staph aureus, and Staph epidermidis, and on occasion, Candida albicans, although that is often said to be in a disease state. But the point that I'm making here is if this drug is poisonous to the bacteria which are part of our body that make up, essentially outnumber our human cells by 10 to 1, they are not just in the gut and on the skin, but they've even been found in the brains of healthy people, that this drug is poisonous to them. So that could have a deleterious effect on our health and may explain some of the toxicity that has been reported in the literature. And finally, it has been looked at in Alzheimer's disease and neurodegenerative disorders more generally, but really only theoretically. And there are animal studies, and I think there might even be one small human study for Alzheimer's disease. But essentially, all they can conclude from these studies is that there is promise that it may be a useful treatment. So I'll read what they wrote here. Animal studies and clinical trials have demonstrated its potential to improve cognitive function, reduce oxidative stress, and protect against neurodegeneration. However, some studies have found adverse effects and safety concerns with methylene blue. Existing studies have limitations such as small sample sizes, short treatment durations, and dosage and administration route differences. While methylene blue shows promise as a treatment for neurological disorders, further research is needed to determine its safety and efficacy, which is how well it works. So in other words, they've done some studies and they couldn't really tell if it is worth it or not. So, and of course, they were limited by some adverse effects. So now that we've looked at all of the potential therapeutic benefits that have been studied, let's now look at the other side. So I'll start here, and this is also from PubChem, as I mentioned, and this is just some general information like that is required for labeling and other purposes. And so here we can see that it is classified in these pictograms as a corrosive and an irritant. So that's generally not the kind of thing that you want to put in your veins. Under the hazard statements here, it says harmful if swallowed, causes serious eye damage, harmful to aquatic life with long-lasting effects. So not very optimal warnings. So let's go on. And this is from a different website, but also a government website. And here it reviews some of the adverse effects, the toxicity, and contraindications. And I think some of these are quite important. So one thing is, and I'm going to talk about this a little bit more at the end, that it has an interaction with antidepressant drugs, that if it's combined with those, it could cause a very serious or life-threatening condition called serotonin syndrome. And also in adults, it can cause central nervous system problems. But in neonates, it is really, really toxic and can cause respiratory depression, liver problems, fluid in the lungs, and hemolytic anemia, basically where your red blood cells fall apart, and that itself can be fatal if it's severe. And There also are reported allergies, including anaphylactic reactions to this drug. It's contraindicated in pregnant women because of a variety of birth defects and fetal death when it was used in amniocentesis. And there is no antidote to treat toxicity if there is an acute overdose. Now, if we look at the toxicity summary from PubChem, we see that it can induce methemoglobinemia, as I noted before, especially in people with G6PD deficiency, which is a not that uncommon condition. And it also, as I mentioned before, that it's severely toxic to the eyes. So it's very important not to get it on your eyes if you are going to use this, because it can damage the cornea and the iris. We talked about the allergic reactions, that it causes birth defects. We talked about, so the hemolytic anemia that I mentioned has also occurred in animal studies, so not just in human neonates. And animals have had other different problems, including splenomegaly, which is enlargement of the spleen. And it was also toxic to embryos in the rat. And in the mice, it caused preterm delivery of the babies. Now, looking at it in the laboratory outside of animals, it induced DNA damage in cell-free conditions. It was mutagenic in cultured mammalian cells. And also, cats, dogs, and horses are very sensitive to it. So make sure to keep it away from your pets. So these are a list of drug warnings and contraindications. So there are quite a number of things here. It has to be injected carefully and slowly because of its irritant properties. Of course, you can't give it to pregnant women or women you suspect may be pregnant, people with anemia, etc. So there's and people with kidney impairment also, it has to be adjusted or possibly avoided. So there are many, many reasons within standard medicine that they would not give this drug. And I have even more on this page. So it's definitely something that we have to be careful with. And here is the last slide that I'll mention, because of that combination with antidepressant drugs and causing serotonin syndrome, they actually did a study to look at if it inhibits an enzyme called monoamine oxidase. And that's an enzyme involved in the synthesis of these neurotransmitters like serotonin, and I believe dopamine as well. And there are some older antidepressants which inhibit monoamine oxidase. And in fact, also one of the substances that's used in ayahuasca ceremonies also inhibits monoamine oxidase. And that's one of the reasons why they would always tell you to stop taking your medications before you do an ayahuasca ceremony, because when you have an MAO inhibitor combined with another serotonin drug, like an antidepressant, that's when you have an increased likelihood of this toxicity. Now, I'll tell you that when I was trained in psychiatry, MAOs inhibitors were really considered too toxic to even use at all, like only for extremely, extremely refractory cases. And I only, saw one or two patients out of thousands that were prescribed these drugs because of these side effects. So this study actually showed that methylene blue is an MAO inhibitor, and this explains why it is responsible for that type of toxicity. So I want to summarize and wrap up my points here, which is that, we see many alternative therapies, and some of them are actually pharmaceuticals but used outside the mainstream. But many times there is an excitement about these materials, and perhaps some of the interest in methylene blue is because it's not used much in the mainstream, that maybe, there's some value to it, but it's not profitable. But I think we have the burden of carefully investigating all of these substances to see, is there really evidence that this is something that can help our health and help our body heal and optimize its health? Or is this something that is, a trap or really is toxic and there's no clear benefit from it? And I think methylene blue falls in that latter category, that even the main thing that it's supposed to be used for, it can cause the same problem. We haven't seen evidence of any clear, meaningful benefit in any of the clinical studies that I was able to find. I also didn't find long lists of people's anecdotes where they had amazing results from methylene blue. And we have clearly a lot of toxicity and potential toxicity, a lot of contraindications. And if we think about the origins of where this chemical came and the historical significance, that it's the first fully synthetic pharmaceutical, it came from a chemical company that was in cahoots with the Nazis and now is part of the GMO big agribusiness industry. And it is not really coming from nice origins. It's not a natural substance, and it doesn't have any clear benefit to nearly outweigh all of the risks that I've outlined today. So I think it's clear that my opinion is there's no major recommendation that I would have to use methylene blue for any clinical condition. I would even hesitate to use it in methemoglobinemia, to be honest, because I think there are other options, like even vitamin C can help ameliorate that condition. And there's probably even better ways using natural healing. So I think we should continue to look on for other substances that have clear benefits and very, very low, if any, risks. This has been another episode of the True Health Report, and I look forward to seeing you in the next one.